Using deep learning and transformer based models, we used the MetaData drug review dataset, which contains patient reviews, ratings, conditions, and usefulness counts. The goal is to predict sentiment, negative, neutral, or positive, and provide an oral recommendation for a drug. Let's start from the beginning. First, we performed exploratory data analysis. We analyzed data, rating distributions, and converted ratings into three sentiments. These three sentiments are positive, negative, and neutral. And we classified them based on the ratings less than or equal to 3 and were labeled negative, and 4 to 7 neutral, and above 7 as positive. These are the ratings. We also cleaned the review text by removing special characters by removing the special characters, URLs, and extra spaces. Additionally, we used useful count as the metadata to improve the prediction performance. While all these keeping aside, I performed the CNN and combined with Glow. As a baseline, we implemented a CNN model with Glow embeddings. The model uses convolution layers to extract local textual features from drug reviews. Although CNN is performed reasonably well, it struggled to capture contextual meaning it made in medical terminology. Here is the CNN performances and all, along with the embeddings, Glow embedding. We also integrated the metadata to acquire better performance. After the embeddings all the input layers, embedding, convolution layers, input layers, max pooling, dense the layers, and again densing, and then dropout. This is the final output we got. And by running some epochs, we got an accuracy of 0.91, but there is a more difference between the accuracy and validation accuracy, which is not considered as a better option. And the final test accuracy we acquired is 0.75. This is the graph showing the differences between the CNN Glow training accuracy and validation accuracy. This range is not preferably correct. And then from these feedback, we moved to Distilbert. We used Distilbert because it is a lightweight transformer model. Distilbert improved performance because it captures conceptual relationship between the words. Distilbert can actually understand the language of the vocabulary, and it can get a relationship between the previous word and the current word. So we use a Distilbert, and it performs well better than the CNN and Glow. However, since Distilbert is trained on general text, it still lack a domain specific understanding because we are using the medical terminology, whereas Distilbert cannot understand all the medical terminology. Now I want to show you the results from the Distilbert accuracies. We ran three epochs where we got a better accuracy 0.88 train accuracy, and the test accuracy dropped to 0.84. It's better than it's better compared to the CNN and Glow. Here is the visual representation of the graph between the Distilbert training and validation accuracy. Now let's move to the biobot model, where we completely based on the biomedical terms. So we moved to the domain specific transform model called biobot. Here is our biobot model code. We selected biobot because it is pre-trained on biomedical literature, making it suitable for drug reviews. So we performed it on biobot. We also incorporated metadata using useful count. Here also we cleaned the test by some removing the URLs and all. and then we classified the sentiments into three: negative, neutral, and positive. The architecture combines biobot text embeddings with metadata through a fusion layer. Here we used some fusion layers, dropout and linear, all these are same. But here is the accuracies we perform. In BioBot model, we acquired an accuracy of 0.89, training accuracy and validation accuracy of 0.85. Here we can see the difference between the training accuracy and validation accuracy is low, which is more preferable in ML and DL. So we acquired some good accuracies and all. Here is the final result in a test accuracy of 0.89, which is very much good compared to the other models. So this is such a good model so far. Later, this is what we attained. This is the output of where it shows some drug reviews biobot models, from which whenever we give a drug name is a data inside input, it shows the some confidence scores and also the overall from the data set, which review got how many input outputs and all, what is the percentage of the negative, neutral, and positive. For better understanding, finally we deployed the model using Streamlit to create an interactive web application. Here is my code. A user can enter a drug name and the system analyzes all the related data, reviews. The application displays sentiment distribution, average confidence, sentiment distribution, and also the average confidence of the recommendation, and also an overall recommendation whether what is a mostly positive. Here, in whenever I give an input here drug name, it analyzes all the reviews and gives me the simplified better review. We also show sample reviews and a pie chart for a visualization. This makes the model useful for real world decision support. And also we ends with this, like, this completes the drug review sentiment analysis project using BioBot and Streamlit deployment. Thank you.